Hello, Learn STEM. Today we will be talking about tissues. Firstly, I wanted to kind of go over the levels of biological organization because sometimes it can get confusing as to which level we're talking about. So obviously we are first starting with atoms, and those atoms create molecules, which create organelles, which isn't pictured here, but those organelles form cells, then those cells form tissue. So histology studies tissues, and what a tissue is, it's a group of cells with similar structure, and also they all have a related function. So we will be going into tissues. There are four types of tissues, but in this episode, we will only cover epithelial tissue, and the other three will be covered in the future, because epithelial and connective tissue, they are more dense, at least in this curriculum. They have a lot more things to be discussed. So right now we are just focusing on epithelial tissue. And things to know about epithelial tissue, just broadly, is that there are two kinds of them. There is the covering and lining epithelium and also glandular epithelium. There's also six functions of epithelial tissue, and it is protection, absorption, filtration, secretion, excretion, and also sensory reception. And what is circled in the picture, these are epithelial tissue, but they are more specifically types of covering and lining epithelium, which we will be covering. And in covering and lining epithelium, which is what we are talking about now, there are 5 distinguishing characteristics. The first of them is polarity. So what polarity means is that there is an apical and a basal surface. So the apical, as you can see from the diagram, is the free surface. It's on the surface, the top of it, the top of the epithelium, and then the basal surface is on the opposite side, and it's on the bottom of the epithelium. So in this picture, it doesn't have it, but in this diagram, it shows that the apical surface can have microvilli and cilia. So microvilli, they're on the left here. They are finger-like. They look, more stubby than the right, which is cilia. They're finger-like extensions of the membrane to increase surface area, and this actually helps with absorption and secretion. And on the right side, we have cilia, which are more hair-like, and they help to propel substances. The basal lamina, it can be seen here, is adjacent to the basal surface. As you can see, the basal surface is right below this pink part, which is part of the epithelium, but the basal lamina is right below it. And this part actually acts as a selective filter from taking things in from the connective tissue, and it filters them if it's go through to the epithelium. Next is specialized contacts. This just means that epithelium, they form sheets. And this is specifically in covering and lining epithelium, not glandular epithelium. So how they do this is through tight junctions and desmosomes that connect the epithelium together. Because when you think of them, it's like this. They form sheets, and they're very tightly connected. So next, we're going to be talking about how they are supported by connective tissue. Obviously, we won't be covering connective tissue here, but in the next video. But deep to the basal lamina that we were talking about earlier is the reticular lamina, and this is actually part of the connective tissue, but it's also part of the basement membrane, since it's the basal lamina and the reticular lamina make up the basement membrane. And how this reticular lamina works is that it is actually made up of collagen protein fibers. And what collagen does is it provides strength, structure, and support to skin, muscle, bones, and connective tissue. The next two are a bit more self-explanatory, because epithelium is avascular but innervated, which just means that it contains no blood vessels, but it is supplied by nerve fibers. And finally, regeneration. Epithelial has a high regenerative capacity, and this is because, like, if you think about skin, it's exposed to friction, and the surface of the epithelia, it can rub off pretty easily. And also, it can be damaged by hostile substances from the external world, like bacteria or smoke. And because of this, epithelia can actually reproduce a lot as long as they have adequate nutrition from the body. Now that we discussed the 5 distinguishing characteristics of epithelia, how do we classify it? So you just asked 2 questions. Number 1, how many layers are there, and what is the shape of the cells? If there is 1 layer, then it is simple epithelia, and if it is greater than 1, then this is stratified epithelia. Then when you take that simple and stratified, you also have to tack on the shape to name the type of epithelia. There is squamous, cuboidal, and columnar. They take on the shape of their name, or the name was named after their shape. So it's pretty easy to determine which one is which, because squamous is more squished, it's flat, and cuboidal is like a cube, and columnar is columnar. It looks like a column. So you may be asking, if it's stratified, if there are multiple layers, then which shape is it named? Because maybe the top layer is squamous, but as you go down, it looks more cuboidal. Well, you're going to name according to the apical, which is the surface, the top layer. With this, there are also more specialized types of shapes, I guess. So there is transitional epithelia, which can either be smaller to larger from the bottom to the top, or larger to smaller from the bottom to the top. And there's also pseudostratified, which, as its name suggests, it looks stratified, but it really isn't, because as you can see, a lot of these cells it looks like there's multiple layers, but a lot of them go straight to the top. And the ones that aren't, as you can see, they get kind of cut off because some cells get in the way and reach all the way to the top. They vary in height. So the small ones that kind of get cut off, they kind of have less of a function since they don't reach to the top of, the epithelium. Through this table, it's more easy to get a hold on what shape and what type has what function. So as you can see, the simple squamous allows a lot of things to pass through with diffusion and filtration because it's so thin. Structure reflects function, and it can also secrete substances. Then a simple cuboidal secretes and absorbs, and simple columnar secretes and absorbs. So what we can take from this is that simple squamous allows diffusion, and usually when the epithelium is simple, whether it's squamous, cuboidal, or columnar, protection isn't the most important thing to the epithelium. So for your skin, that would not be simple because it can easily rub off or get damaged, like I said. So it needs to be regenerated. But for other things in your body, if it just needs to secrete and absorb substances, then the epithelium does not need to be stratified. So, like I said, if you look here at the stratified sections, squamous, cuboidal, and columnar, one thing they all have in common in the function row is that they all protect. And this is because there are rows upon rows that can be easily pushed to the top because that's how tissue regenerates, epithelial tissue regenerates. The new comes in from the bottom and it pushes to the top. So if there's more layers, then this protects against abrasion. It's protective tissue. And again, you can see that cuboidal and columnar are more for secretion, which is the same as their simple counterparts. And this is because, again, their structure is reflected in their shape. Because they're larger than the squamous, they can hold substances and be able to secrete them. So just to do an overview, simple epithelia is mainly used, its main functions are absorption, secretion, and filtration, while stratified epithelia is more for protection because it is more durable than simple epithelia. And as you can see on the bottom, there is the transitional epithelium. And you can see here in its function that it allows the urinary organs to expand and stretch. So if we go back to the previous slide, you can see how it transitions from a larger cell to the smaller. And this is because in the bladder, as it fills up with urine, then the transitional epithelia can actually stretch and expand so that it has more room and it can hold that urine until you have to go use the bathroom. Okay, next is the glandular epithelia, because we were just talking about covering and lining epithelia. So as the name suggests, glandular epithelia has to do with glands. So glandular epithelia is one or more cells that secrete and make fluids. More specifically, it's aqueous fluid. So they get substances from the blood and transform it chemically to be able to secrete it. In classification, you asked, again, two questions. Where does it secrete and how many cells are there? So in the first question, where does it secrete? It can either secrete internally, which is endocrine, and externally, which is exocrine. Then secondly, there is how many cells, unicellular or multicellular. In endocrine glands, these are ductless. As you can see, there isn't a duct to be able to secrete the hormones like there is in exocrine glands. So endocrine glands are ductless, like I said, and these are the ones that produce hormones. And these hormones are secreted through exocytosis directly into the extracellular space. These are also mostly multicellular. Next is the exocrine glands. And as I said, how the endocrine gland is ductless, this one has a duct. You can see that there's an opening, whereas this one isn't, because remember, endocrine is internal and exocrine is external. So exocrine glands, they secrete directly onto body surfaces, directly onto them, or into body cavities. So you can see this in the form of mucus, sweat, oil, in your salivary glands, in your liver as bile. These are also mostly unicellular, and there's two types. There's mucus and goblet cells. So unicellular is your mucus and goblet cells. They are similar, but they both produce mucin that dissolves in water, and when it's actually secreted, it forms mucus, which protects and lubricates surfaces. Mucin in goblet cells, you can see how it goes to the top, which gives it that goblet shape for which it was named. So that was the unicellular exocrine glands, and next is the multicellular exocrine glands. So firstly, there are two parts, the duct and the secretory unit, and these are classified by their structure and the type of secretion. As you can see from the table, simple glands are unbranched, while compound glands on the right have branched ducts. The glands are then again categorized by their secretory units, which can either be tubular or alveolar. So you can see that tubular, it looks, more like a tube. And then the alveolar, they are kind of like sacs, which alveolar, it comes from a word and it means a small hollow cavity. What's not pictured on this table though is they can actually also be tubulo-alveolar, which is just like it sounds. Some structures are tubular and some are alveolar. So then with this, they can be structurally classified, which is shown. They can also be classified through their modes of secretion. So there is merocrine, apocrine, and halocrine, and most of these multicellular exocrine glands are going to be merocrine, which just means that they secrete their products through exocytosis while they are being produced. So the secretory cells, they're not changed in any way, like the pancreas, most sweat glands, and also salivary glands, they are merocrine. Then there are holocrine glands, and these, they kind of accumulate their products within them until they rupture. So where the merocrine glands, as the secretory product is being produced, it is being released through exocytosis. Apocrine, it just holds it in until it ruptures. Then there are the apocrine glands. They are present in other animals, but we don't know yet whether they are present in humans. So like the holocrine glands, apocrine glands, they also accumulate their products, but with holocrine or apocrine glands, they only just they're only just beneath the free surface. So basically the apex of the cell pinches off of the apical portion of the cell, and then it releases the secretory granules in a small amount of cytoplasm. Then the cell repairs its damage, and then the process repeats again and again. Those were the types of epithelial tissue, and I hope you learned something from the video. Subscribe to Learn STEM on YouTube, and you can listen on Spotify, Apple Podcasts, or wherever you get your podcasts. We post every Sunday, except for last Sunday because Labor Day weekend. Thank you for watching.